Hey everyone, welcome to the replay here. This is Eric Wright. This is a replay of my presentation that I gave at the AWS Summit in Toronto on October the 3rd. I'm re-recording it in the evening because I could not record the live session. So with that, we're going to get started. My name is Eric Wright. I'm the technology evangelist at Turbonomic, and today's presentation is called Open Source Infrastructure as Code with Terraform and AWS. Now, the question that comes up is really, what are we going to cover today? The number one question has to begin with why Terraform. I'm going to talk about why I'm excited about Terraform, where I've used it, and the reason why I think about automated provisioning and the value of doing so. The Terraform open source versus Terraform Cloud, which is a newly available platform that you can get for free, in fact. Building a first very simple deployment, so a good example of how to use Terraform to do a very quick deployment, get your feet wet, and then I'm going to go through what I call the super cool classroom use case. You're going to get a sense of what that is. I'll tell you about how I've actually used this at Turbonomic in a very specific cool case. It begins, of course, with understanding why. You have to know what it is that you're doing in order to get value from some technology or some process improvement. And definitely when I think about Terraform and what it does, this is the challenge that we face as technologists. Every day we're trying to find consistency. We're trying to find sort of balance in doing the right things where we can do things manually because they have to be done, automate as much as possible. And really, the reason is because we want consistency. We don't want this constant changing, fluctuating problem of how to manage infrastructure. And the challenge we've got always is, what are tools that I can use to get consistency of outcome? And I've done a ton of stuff around building, shell scripts and PowerShell stuff. And while that's neat and it solves specific problems, it doesn't really work for true ground-up provisioning. And I have a problem where I've had to think about multiple different platforms on which I need to do this on. Worst is that as a practice in IT, we generally broadly accept that everything's okay, even though we're doing way too many things manually, we're way too inconsistent, and even if we're using tools, only single people on teams are able to use them. And I've talked a long time about getting value from different products, and I've used them. However, when you go to collaborate with a team, you have to think in a different sense around systemizing the approach that your team's taking. And ultimately, the goal here is to never send a human to do a machine's job, as my good friend Agent Smith from The Matrix has said. I love this quote and I love this idea because I don't believe that automation replaces humans. What I believe it does is it lets humans replace that wasted time with doing something of higher second and third order value. So why Terraform? On the bottom there, you can actually see there's a graph, which is the Google Trends graph for people searching for Terraform. And if we look at it, I kind of like that there's these three dips there, which is kind of funny. I guess that's December. Apparently, Terraform not so popular at the end of the year around Christmas, so kind of nice. Everybody's taking Christmas off and the end of the season. But Terraform is a way to do provisioning with codified representation of infrastructure. It's a nice way of saying infrastructure is code, but how do you represent it as a desired state of what you're looking to achieve, and then making sure that relative to the current state, that's what's actually going to happen. It can easily be used with version control. So this is the cool thing, being able to take stuff. Right now, I know the version control you're using because I do the same thing. You have production launch _1 dot doesn't work dot DS1, whatever, all your different things. You've got PowerShell scripts, you've got all these other desired state scripts, you've got bash scripts, and they're versioned and copied and shared amongst teams. And even worse, they're not idempotent or idempotent, however you want to say that. Really, what it is if you run them more than once, bad things can happen because they're not really built to understand current state, future state, and desired state. The good thing about Terraform as well, it's open source and widely used. Open source is not meant to solve every problem in the world. However, looking at the actual contributions, there's many, many different contributors to the Terraform platform on the open source side. So it's not just HashiCorp that are doing it. Folks from all the different platforms, from the cloud platforms, from applications, there are literally dozens upon dozens of providers that are available. The providers also go from infrastructure up to the applications and different configurations like load balancers and such, network equipment. There's really, really a ton of great opportunities. So whatever you're running, if you go to terraform.io, you can check the provider list. And really, when I'm thinking about it in the context of AWS, there's a ton of service coverage. So really significant, broad coverage of many, many different AWS services. It's not just IaaS. So even if you're going in to do ECS and you're doing other, higher level services with containers and Route 53 and networking and VPC, that's all able to be managed and provisioned using Terraform. It's DevOps friendly. So if you're looking at collaborating between teams, there's no better way than to use tools that can actually be collaborated with. And really, it's limited amounts of experience on code required. I've proven that out because I'm not a coder at heart. I do enough coding to get by, but that's it. So I've been able to tackle this, and in fact, the stuff I'm going to show you today is converted from open source scripts. And this is why I want to talk about this next important subject. So I've used Terraform open source for a long time. It's a CLI-based tool, super cool, freely available, no limitations on it as far as like using it and sharing it out. But then all of a sudden, at the recent HashiConf, which just happened in, I think it was like September of 2019 here, they announced Terraform Cloud. Now, I've been using this in beta for a while. It's effectively like a light version of Terraform Enterprise. It's free, available for teams. So I think it's like small teams, maybe up to 10. Don't quote me, but ultimately it's free, especially for a single user. So you can go in, you can set up workspaces, you can do all sorts of stuff. This is amazing, right? Because I've been using it on the open source side, but the problem was getting people onboarded to understand how to use it wholly and solely from the CLI. So now what we have is not only neat ways to interact with it, but centralized state management. Before, what you'd have is your state is held locally on the machine on which you run the Terraform binary. So the problem is if you run it on your laptop or your desktop or on a central server, that's where state is maintained. So you can't really effectively collaborate. Some people are hosting state files on S3, but then there's issues with locking. There's a lot of things that have led us to need this. So now you have out-of-the-box centralized state management to share between team members. You can collaborate now across folks in your own department. You can do that kind of DevOps practice, so use the same tool to provision. Not only that, but it's got security and governance baked in. So this is cool. It's kind of like I said, Enterprise Lite. The Enterprise has more, but there's a ton of stuff, including secrets management. So you can put in AWS credentials, other types of credentials, mark them as sensitive. I'll show you in the UI itself. And then once you do that, they're actually held securely and you can never get them back. So that means that you can put in the credentials once, no one on the team needs to know them, and that's it. You don't have to store them in code, which is pretty much the bad thing that happens all the time. It also has versioning of state files. So understanding when state changes, it keeps track of the state. So if you say, oh, goodness gracious, Eric ran something 3 times and it worked fine, but then 2 other people on the team ran something and then something went wrong, you can go back through each iteration of the state files and also the run configurations because it's tied in with version control. You can choose to run locally or remote, so you can actually run centrally in the web UI and trigger it via APIs and such. Very, very cool because I launched it from a mobile phone. I was able to interact with it very easily. But you can still run locally as needed if you want to, and then you just use it for central state management, so you can still collaborate as a team. It's got a full app UI, like I said, it's HTML friendly. It also has webhooks and notifications, so you'll see what it looks like. I've actually got it connected to Slack, which is an out-of-the-box integration, so super fast. And it's fully API accessible. So that means that ultimately you can just jump in. You can use the API to trigger runs and plans and manage them. So even if you're not ready yet, you know that it's kind of future friendly to make sure that you can do that as we look at integrating with stuff like CI/CD frameworks. Now, interpolation, for folks that are straight up sysadmins like I was and still am, really, interpolation is a neat concept. I think of it as the dandelion effect. You can plant a dandelion, then it plants future dandelions. And that's really what it is being able to say that, number one, Terraform does resource management and reorders it for you. So even if you've got stuff that's out of order, it loads it all into memory. And then from there, it will kind of put it in the state that it needs. So if it's got dependencies, it finds them and will mark them out. If you run a Terraform validate, it'll tell you if there's a problem with your syntax. And you run a plan, it'll tell you if something's going to go wrong. But interpolation allows you to take references that are dynamically generated from one resource. Like say you've got a dynamic load balancer and instance groups and such, where you need to attach things where you don't know what the name of the machine is going to be. So you get the instance name or the instance IP as outputs dynamically, and then you feed that into, as a variable, the next resource. So very, very cool. You can actually use references from one thing dynamically into another. Now, the example code that I share here, and I'm going to give you the link to, it's in the blog if you found the blog already, or if you use the link in the presentation. There are some hard-coded references. I'm going to fix this as we go. I'll kind of mark it that it's been done. But it was kind of to show that you can take a look at what it looks like, and you'll get ideas of where it needs to be improved. And I didn't fully variablify it, as I call it. But a second disclaimer, of course, that variablify probably is not a real word. But what it means for me is that I'm going to go in. Some stuff is hard-coded, like the name of the machine that I'm using in one of the scripts, the name of the VPC, so the VPC ID, stuff like that. Some of that needs to be moved into either environment variables or something like that. Also, OSS versus cloud, big thing to notice for differentiation. You cannot gather user input interactively when you're using the cloud platform, whereas you can do that when you run local. So if you run remotely and you're using the cloud in order to launch it, it can't generate input. So if you're missing a variable and it's not assigned, or like a value is not assigned into a variable, it will stop and it'll fail because it doesn't know how to gather input because it's running in a container in the actual Terraform cloud. So what you're going to need is Terraform 0.12 or higher. And the reason is because there was a fundamental change in the format for Terraform configuration. So very, very cool. You have to go and upgrade. There's a few things. I'm going to do a separate blog on running upgrades because I found people have asked that a lot. You're going to need a Terraform cloud account, so go to app.terraform.io or go to terraform.io and you can sign up for a free cloud account. You can create an organization. Inside there, you create workspaces, and each workspace is going to be a set of configuration files. You get an API token that you use. It's a user token so that you can actually then run that locally. You set it up into your Terraform RC file. We're not going to show that today, but I'll do that in some future blogs as well. In this case, I'm going to use an AWS client key and secret file. And that gets us right to the next step, right? Which is actually, let's take a look at what it needs in order to run a very simple deployment. And I wanted to start as the most simple possible step. Now, starting with the basics is we're going to use an EC2 instance, and, well, actually, that's it. That's seriously all we're going to do is we're going to just launch an EC2 instance, and I'll show you what the code is in order to do that. Blindingly simple, really. You can see the provider stanza at the top here. So what that shows is that, just go back there. So the provider stanza, we've got it marked here. Ooh, boy, it doesn't like that. So it is showing that we have AWS access key, we've got a secret key, and we're assigning a region because we need to be able to set this up. There's other things that are going to be region dependent. And then in order to set it up for Terraform Cloud, you set a backend stanza. So this whole stanza here shows that we're using a backend. This is the name of my organization. Remember how I said it wasn't variablified? So this has to be replaced if you want to run this, but these are great examples to show you where it's coming from, and you'll see in my example specifically where it comes from. And then this is the actual EC2 instance itself. So it's an AWS instance. It's super simple. I'm calling it web. You can call it whatever you want. Here's the AMI. That's right, folks. I call it an AMI. So shout outs to Quinny Pig on Twitter, who's a must follow for many reasons. But Corey Quinn he's the Duckbill Consulting Group. Wicked funny, super smart fellow, a good human, and also kind of makes fun of the fact that some people apparently call these amis, and I'm French, so I can't say ami without sort of smiling and laughing. So it is an AMI. The instance type in this case, we're going to set what size it's going to be and what type it's going to be. I'm telling it there's a key name which is going to come from a variable. I'll show you where that variable comes from, and I'm going to drop a couple of tags on there. Here's some. It's just like when you buy a dog. Always tag your pets, kids, because when you use things like tags, you can do other programmatic things based on the tag availability. I use this because at Turbonomic, I can do policies and stuff by tag, and there's lots of platforms that are using tagging as a way to mark things for particular activities. So I'm actually going to jump in. We're going to get out of here, and we're going to just get right into it. Get rid of those. So this is the real deal. You are looking to be looking at a live installation. So here is my configuration. I've got a couple of different workspaces because we're going to use 2 different workspaces for the example today. Number one is this very simple one. It's called AWS Summit Toronto. Now you're going to see a few different runs that have actually occurred because I did the demo earlier today and I tested things out. The state file as well, like I said, central state management. So if we actually take a look, it tells you what the state is. So right now, pretty empty because there are actually no resources because I destroyed the resources in an earlier run. The variables, as I mentioned here, so these ones are specific to my configuration. Don't worry, it's safe because you don't have access to this one. It's my own VPC that's inside my own account. But this is the way that you can actually capture the fingerprints for my SSH key and the key name that I've attached to it. So this is stuff that's specific, and then you can see here where it says sensitive, write only. So if we dig in, that's it. So that means what I've done is I've gone in and I've created it, and I'll show you quickly. If you say add a variable and you type it in and you hit sensitive, it will actually mark it and then it just hides it. From that point on, the only way to adjust it is to remove it and recreate it. So you can never actually query and get that sensitive variable back. Here, I've actually ignored this. This is confirm destroy because I wanted to actually destroy the previous build, and you need this in order to do it. It's a nice little safety mechanism. Now, to top that off, let's take a look at what we've got here. So, general configuration. Here's going to be the name. I'm saying that I'm going to run this remotely. You can also choose to have it locally. We can say whether it's auto apply or manual. By default, it's manual. What this means is that if I go and I do a test, and I run a plan, and it succeeds in the plan, it will actually then immediately head to a run if you set it as auto-apply. Here it's actually going to stop and confirm. And Terraform version. So by default, it will pick it up when you do the run, but you can actually hard code it if you've got specifics. I do recommend, of course, like I said, 0.12 and higher for a variety of reasons, and really you'll get better consistency because it's much more friendly in the way that some of the resources are managed. There's a lot more to it, but that's just all I'd say. Run 12 or higher. It's just much easier. So if I take a look at this now, let's actually take a look at the code because I remembered we talked about this. So here is what the actual configuration is, just like it was in the presentation. And let's go out to the command line and see what's going on. So this is my first example. I'm going to clear my screen, say Terraform show. We're going to see there, it's like the old magic trick. As you can see, ladies and gentlemen, there's nothing up my sleeves. There literally is nothing there. So if I say Terraform plan, what it's doing now is, and it'll actually pop up in a second, it's going to run the plan C with a remote backend. And what it's going to do is it's going to stream the output here. If you actually stopped it, the plan is still running. And it even tells you specifically how to get there. Like you can actually clip this and go and find it. But what's even cooler, at the same time, I actually turned on notifications. So what's happening is it's actually going to go through and it will write out to Slack. It's got a native connection with Slack. I've set it to go into a specific channel, and so I'm actually going to get information there. So it's going to take a second. It shows I've got one to add. So now we're good there. So the run is ready. Let's go back to the web UI. Okay, cool. And we are good. Okay, so we're clean there. It's actually ready to go here. So let's go and let's do the same thing on the cloud because I've set this one to run remotely. So I'm going to say, go for it. Run QPlan. And here we go. You may have heard that pop up. That's what it is. Okay, so here we go. This is the run that's actually configured, and it natively plops this out into your Slack channel, which is super cool. So let's just wait a second and watch it happen. If you needed to, you could actually click that link right in Slack. So you don't even need to be watching it. If someone else on your team does this, you're going to get the notification. So we see what's going on here. It says, life is good. You've got 1 to add, 0 to change. Oh, look at that. I heard another pop there. The pop says run planned, needs confirmation. Right, because it says you've got something to do. So you can either discard it. You can mark some comments there. I'm going to say deploy my good friend. And I say confirm. And let's let this go. And it'll just take a moment. And as if by magic, it's slowly going along. A few seconds have elapsed. We're watching this in real time, which I kind of don't recommend, depending on how big it is. This is just a simple EC2 instance. So there it is. It's done. Now, if I go through, I heard my little doodad there, and here he is. So we've actually got Slack notified me that the run is completed. We can go back. We can check the state. Remember before I talked about centralized state? So not only here's the actual state, it shows you where the run is. It shows you if you actually configure the state. We can expand this. We'll see what the actual state is. You'll recognize this as JSON or HCL as well. HCL is a nice way of saying HashiCorp configuration language, which happens to look like JSON, slightly different. A deeper subject to talk about there. And then to top it off, if we actually look at this, what's really cool is it shows if there's any configuration in code. And I'm gonna go a bit further than I actually did in the previous session. Let's take a look at this. So I'm going to say this is T2 micro. What if I wanted to change something? So I say T2 nano. Let's jump out. So my Terraform show, it's going to say Terraform is ready to go. And then, oh, I've made an actual change. So let's just see what happens. So we run Terraform show. It goes back to the central state. This is what's going on. I say Terraform plan. Now you can run a plan from anywhere. It only will pop out the output to my Slack if I run it on the actual web UI. It's going to take a moment. Again, it's triggering the plan based on centralized and shared state. It's going to recognize, here's spoiler alert, it's going to see that something's different, and it should say, look at that, one to change, right? So it's recognized that I've suggested that something needs to change. It'll take a second there. It's going to unlock the state check. Remember, locking is super cool because it does each of these things. It actually locks it while it does that. So I'm going to say git status. Here's a neat thing. I've actually configured this. So I'm going to say git add main.tf. So I'm going to commit that. And I'm going to say updating instance size git push. Okay, so here's what happened. I've actually connected this to a GitHub repo, which is where the code's being stored. And I actually just heard a pop. If I go through it, it says, oh, hang on a second. There's a run plan. If we go back, let's take a look at the runs, and you'll show my doing a git push triggered. I've got it set. Here, let's take a look and see how it goes. So if I look at version control here, you set it to what the provider is. You set it whether it's always triggers a run, or you can set it to only trigger with a specific path change. So I can set a file called like trigger or run or whatever it's going to be. Update that specific file. You can set the branch, include submodules. So I go back to the run, and it says, all right, something's here. I'm going to do a plan. I see one change, just like we did when we did the test plan. I say confirm, go big or go home. So we want to upgrade our instance size. We say confirm. And now, I don't even know if you, actually, I don't know if you hear that. I hear a little boop, boop, boop coming out of Slack. It's coming into my headphones. Now it's going to go ahead and run. So, hey, spoiler alert, we don't need to watch that. I won't bore you with watching this for the 3 minutes while it takes while that instance restarts. Let's jump back in and we'll take a look at where we go next. Okay, so the simple EC2 deployment is done. It was meant to just illustrate how the interaction works with your version control system and how you can do this. So we've got a bigger plan next, and I kind of use Abe Lincoln's classic thing where he says, if you give me 6 hours to chop down a tree, I'll spend the first 4 sharpening the axe. And what this means to me is that if you give me a specific task to do, I'm going to do everything I can to make the process smoother and better. I'm going to automate as much as possible, and this is a great example of how to do that. So my super cool classroom use case is, in fact, we use this internally for some training. It's a slick way for us to get a Turbonomic instance up and running with a little bit of a demo configuration already preloaded into it. So I've created an AMI, so an actual Amazon machine image instance. So it's an image that's stored, and I can just cut a new EC2 image off it. It's already licensed, ready to log in and ready to go. So it saves you the kind of 15 minutes of setup time of adding the license, setting up your first targets. And the reason this use case is neat is because it is able to be used as a repeatable public-facing classroom. This is a very simple one where it's just one instance of it, but you'll see it's an EC2 instance that's pulled from an AMI. I use security groups, so of course I'm attaching security groups for port 80, port 443, and SSH in order to remotely manage it. We use an ELB, which is actually an ALB. It's an application load balancer. And I'm using TLS, or as the folks who are old enough like me, we used to call it SSL. So it's TLS using AWS Certificate Manager. So I've got the free, quick and easy add there, or well, not free, but repeatable. And DNS, that's going to be set up with Route 53 so that it uses fully qualified DNS, attaches, it certifies that it's the right TLS. And this is actually, if you're looking at just the presentation, or you've been sent this link or seen this will point back to a blog, which I'm going to update with this video, the presentation file itself, and you get links to the code, which are sitting out in GitHub. This is the actual topology of what we're going to do. So the super cool classroom looks like this. You've got our users, so our users that come in, so that's us. We actually go through our browser. We go to, in this case, I'm going to call it cert33.turbonomiclabs.com. You'll see that in the code, whatever you want it to be. And then it goes in, it's inside of VPC. It grabs my ALB. The ALB goes out, gathers a certificate check, confirms it. You're going to get a valid certificate. Then it points internally over HTTPS to EC2, where it's already my preloaded image. And then ultimately, this is all protected by the VPC rather. So it's not even a super complex thing, but the point is that this would be about 15, 20, maybe more minutes. Like it's 20 if you know what you're doing. But doing all this setup is manual. It's probably about 200 clicks altogether. So why wouldn't you want to do this in the simplest possible way, especially if it can be repeatable? So let's actually take a look at it in action. Okay, we're going to get rid of our notes there. And let's take a look. Okay, so we're going to go back to our workspaces. Again, this is app.terraform.io. I've got my two, so we looked at the one before, which was the Cloud Summit. This is a Cloud AWS Toronto Classroom example. So let's drill into that one. So we've got you'll see a lot of activity here. Very, very cool. Again, as I mentioned, it's going to use your version control system. You can set the state, so we can go back to different layers of state in case there is an issue. We can look at potentially how to roll back even. We've got variables set. A new variable here, which is AWS Certificate ARN. So this is the Amazon, the AWS resource that we're going to attach. So it's the ARN identifier. And this is going to make sure that it uses, my key. It's going to use my ARN. It's going to use my VPC. I'm going to run this in US East 2, go Cincinnati. So this is sitting in Ohio. And if I go to my settings, they look similar to the other one. So nothing out of the ordinary. And again, version control is set, so it's actually pulling from GitHub. But we're going to interact with it totally just through this particular configuration. So let's take a look. Now what I've got is, if I look at it, I'm going to say cue the plan. Let's say test recorded version, cue the plan. So I hear the little ploop, and I've got myself a notification. Run planning is happening. So again, if I were to just click this, it's going to take me to that same page. So folks that are on your team get notified through Slack. As if we don't have enough noise in our lives. That's a great way to do it. And while it's doing that, let's just quickly look. So here is the actual repos where I'm storing this, so you can get at all the different configurations. There's a couple of things, like I said, that are specific. They're hard-coded. I showed that to you, and we'll take a look at it in a moment. I'm going to look at it in Sublime Text because it's actually a little easier to read. Okay, so this is my classroom. So I've got my provider, like I said, the same thing as before, access, secret, region. I'm putting it in. I set the particular workspace it's going to go to. You run a Terraform init. I didn't go through some of the setup. We'll do that in a separate post. We don't have time covered right now. Here's what I'm going to do. So I'm pulling in availability zones, which are actually set up using another variable, or another file rather. I've got AWS security group, so I'm going to create a security group. It's going to allow port 80, port 22, and 443, and then an egress port to allow it to contact everything. Next up is an EC2 instance. So this is where we set the AMI. It's going to be called cert33. This is actually just, what we want to call the general, you could call this whatever. You could call this Pete. What really matters is the name that you assign it, further down. So it's going to be a T2 large. Most of the stuff is dynamic. Like I said, here's a situation where I'm pulling stuff in that's not dynamically generated. And this is a specific hard-coded AMI that's private to my repo. So when you try and run this, if you did, it would fail for a whole variety of reasons. But you can actually see where to edit stuff, and you could spin up your own. That's why I did the simple instance first. So create target group. Because we're using an ALB, you have to create a target group in which you're going to put your specific instances. It always has to use the VPC ID, so you're going to see that quite a bit because it creates it inside your VCP. We create the application load balancer. I'm going to call it something, again, not dynamic. I statically assigned it for this single instance. So if you want to do it for more than one, same thing here. I've assigned it specific subnets, which can be done through either setting up a specific file or variables that can be defined and passed through to it. I'm going to assign it, give it a tag, and so I can give it a name so I can identify it visibly. And then we're going to say the target group attachment. So we created our target group. We're going to attach it to this. So AWS instant.cert33.id. So it's going to spot where the instance is and attach that into the target group. We've created a listener. So the listener is going to be setting for 443, which is what we want it to. It's got a security policy. This is all, you can actually go to terraform.io, look at the docs. They're super easy to read. It's got great examples there. I've also got a port 80 listener, and this is an automatic, you're going to see it's type redirect here. So forward means it's forwarding the traffic back to the EC2 instance. Redirect is redirecting it to 443. So I'm not going to allow non-secure traffic. It sets it as a 301. Then I create my DNS record, so I'm setting the name of the zone. This is going to be your zone. Notice the trailing dot. It's a Route 53 record, and it's going to look for the zone, find the zone ID based on that. This is all done dynamically. Then it's going to actually put the alias, and the alias is our ALB, so that whatever the ALB is, it's going to be pointed and set to the DNS, and it means it's completely dynamic. And we've got, in this case, simple setup. I haven't set up target health. It really is not much to it. If you look at it, this is 130 lines of code. There's spaces. It's put out in a way that with a little bit of commenting, so it's not really that much. And even though, so here was the subnet that we defined. So we want to make sure that we've got that set. So these are all variables as well that are defined inside. And let's take a look. Back at the actual plan here. So if I go to the plan. Okay, so let's just zoom in for a second. You're going to see it says 8 to add, 0 to change, 0 to destroy. If I actually go through, you're going to see a whole lot of stuff in here, which includes some that's going to show known after apply, which means it's programmatically generated, the different ports, the ALBs. So a lot of this is fully dynamic, some stuff that's actually picked up and assigned, where we manually assign to this. And now it says apply pending. So I go and I'm going to say confirm and apply, build all the things. Confirm and go. I go back. I notice I heard that little sound in the background of my earphones, and it says there's a run applying. So now it's actually locked state. And again, this is what's cool. If I look at the way things are done, right now, it actually doesn't notify here, but it will show you that it is locking the state if you try and run this remotely. And if you set it to run remote, when you run an apply or a plan, you'll get a pop-up in the UI that says there's a lock in place. And you can actually see that visually so that there's no way from 4 people to do the same apply at the same time. This is why shared state management is super important in this. Okay, so there's our code. Like I said, the links are in the blog that you can read if you go to that short link. It's the longest short link you've probably seen. Let's take a look. Go back here. Sorry, I'm jumping around quite a bit. Okay, let's see the runs. It's still showing as applying. Now this one's actually a decent sized beast. So you're going to see it's setting up the target group. It's setting up the instance itself. So instance.ser33, it's going to run through all this different configuration. It's attaching the ARN, so it's actually going to attach the cert to it. You see again, it's US East 2 because you have to do this. So certain resources, be careful. This is a pro tip. Certain resources are region by region, so things like subnets and VPCs, obviously, but even things like Certificate Manager are regional as well. Route 53 is global. There are certain, like IAM is global. So there's a handful of global resources, but some stuff is local. So what you can do is you can actually set up those things as a map, and that's, again, sort of a, let me see an example where we had this, where I had like multiple subnets that were signed. Here's what it is. So you're going to see more than one. So it's basically like a matrix of resources. And so that map allows you to put more than one resource and attach them into a single resource. Probably better ways to describe that if you're actually a programmer. Okay, let's see where we're at. Okay, so right now it's actually creating the AOB. It takes a little bit for that to actually run, but you can see exactly what's going on. So if I were to go back in and take a look, and this is again, like I said, the state. Not only am I showing the state, but if I've got changes that are made, I can actually show where the state has changed, where the change in the version. So in this case, this is all green. There is no version. Remember how we actually changed the version before in that smaller single instance. Let's take a quick look and see what an actual state change looks like. State, we've got the code, so updating instance size. Okay, so here we go. So remember I'd set it and I've moved it. Oh, there you go. There it is. So this is actually pulling from the version control system, which is GitHub in this case. It's a GitHub public repo. You can use private repos as well. You can use GitLab, a few others. And it shows before it was micro, and then it changed to nano. And then ultimately, the public DNS is going to change because, of course, that's dynamic. And by the time you actually go this, if you think you're going to be sneaky and try and attach to it, you actually can't because I'm going to destroy that resource, and that's a very, very dynamic resource because it's a public-facing IP. So don't worry, it's safe that we're doing this and recording it live. Let's go back in. Okay, so it says that a run was applied. Let me just click the link. I'll follow. I'll be a good Slack user. And there we go. Test recorded version, plan finished, apply finished. If I go in and I check the state, so we can see here, if we zoom in a bit again. Sorry, there we go. 8 added, 0 changed, 0 destroyed. Let's go up to our state. And we look and we see what our state is. Here's the actual state and any changes in the version. So this was a 0 to 1, or 0 to 8 in this case. We launched everything. So you're going to see a lot of stuff that's dynamic. Very, very cool. It's super simple. So if you're just getting started with Terraform or using Terraform OSS, I highly recommend taking the jump over. If you go to learn.hashicorp.com, they've got some great guides, including how to set up your initial there's a few things you need to set up your local environment. I'll probably blog on it because, again, it's a popular thing. I can probably show you real quick. But, of course, if you just go to the HashiCorp site, they've got a lot. So that's it. This was the session that I gave. We had a full house. So I would say we're probably about 120 people. We were at capacity. We're actually adding chairs to the area. So big thanks to the folks at AWS. And to Ross Bear specifically. He's super cool. I want to give him thanks and a shout out for inviting me in to be able to be a speaker. And for folks that don't know, Chris, who's at Mistwire, he runs the AWS Portsmouth user group. Wicked good human, a very nice person who's been super helpful to me both as a technologist and as a friend. So he's got me connected up. And so I hope that this is helpful. I definitely do recommend that you go through. You obviously can't complete the session survey and rate this, but I do, if you want to drop in a comment here, if you've got questions, I do hope to keep this interactive. This is a moving target, so of course you're going to see more and more changes with the way that Terraform is being used. So Terraform Cloud right now is free. I say right now, it's suddenly free. Where it's not going to go away. It will continue to be free. It's just a matter of what the features are that are going to switch up. So definitely reach out. My DMs are open. I'm at DiscoPosse. Thanks for watching. I hope you find this helpful, and I hope you enjoy the blog, and we'll see you again at an event in the near future.